live on YouTube, guys. We are now live on YouTube, guys. All right, perfect. All right. So anybody who's over on YouTube will be able to join us and see what we're doing as well. So let's continue here. Let me just talk with you guys for a little bit. So I was saying yesterday that last week we had gone over until 2:30. So if it's okay with you guys, let's just plan on going to 2:30 today. I have a bunch of questions for you guys to do just to make sure that you're comfortable with more concepts. And then if you guys are super comfortable with that and we're ready to move on, then we'll probably move on to another topic today. But more than likely, let's stick with more concept. Do, a bunch of different kinds of questions. There's a wide variety of questions that you could potentially get. So I'm going to walk through each of those today. That's my plan. And then we'll see where we end up from there. But I want this to be a very interactive session. I want you all to participate and to contribute your answers and to write on my screen. Do all of those things, okay? Because I really want you guys to really get the hang of this more concept thing, because everything that we're going to do from here on out is important and we're building on that, okay? So, and as usual, last week I was asking you guys to give me thumbs up so I know to keep going, keep going, keep going. So definitely keep that going this week as well, so I know if you're okay with what I'm saying, because I can't see your beautiful faces, so I don't know if you're like scrunching up your face. I don't know what's going on, okay? So just use your emojis then and let me know if everything is okay, if it's clear, if it's not. And of course, feel free to unmute yourselves and say, Miss, I don't understand, or Miss, that's great. I never thought of it that way. Whatever the case may be, just interact with me and let me know, right? Don't let me be sitting here behind a screen by myself, just chatting all the things about mole concept. I want you to interact. I see that Shani has turned on their camera. Welcome. So guys, feel free to turn on your camera if you want to. I'm not gonna enforce a rule that says no cameras on. Like, I want to see your face. So if you're so inclined, turn on your camera. If not, just unmute yourself and speak with me, okay? All right, so let's get started here. It's 1:05. So let's get started. And so what I'm gonna do is I'm gonna share my screen with you all, and I'm gonna pick up where we left off. So let me share my screen real quick. So we'll just jump back into our mole calculations. So let's see here. Let's see. Master modes. I think this is where we had stopped. I think we had stopped it here. So I'm gonna start here and let somebody do this question for me, just to bring us back up to speed as to where we are, and then we'll proceed. So let me share my screen real quick. So I'm sharing my PowerPoint with you guys. So let me share that slideshow from my current slide. Okay. So that's our mole calculations, right? And I said that there are a wide variety, a lot of different flavors of questions that you can get from mole concept. And really, CXC expects that you as a student will be comfortable going from one thing to another, mass to moles to mass, finding excess reagents when you're given Avogadro's number, Avogadro's law, for problems with molar volumes. They expect you to navigate that as well. And so that's what we're going to focus on today. And I'm going to have you do questions from all different spectrums, all different kinds of angles, and increasing the complexity as we go along to make sure that you're very comfortable with mole concept. Because even if you don't get a question that specifically says mole concept on the exam, it's going to be embedded in a lot of questions that you're going to get. So that's why I'm spending so much time on this. Okay, guys? So let's see who is going to do this first question for me, just to kind of make sure that we're all on the same page going forward. So this question here is asking how many moles of magnesium chloride are present in 38.2 grams of magnesium chloride, right? So this is directly asking you to go from mass to moles. We're given a mass, and we're asked to find out the number of moles. Can any one of my bright sparks tell me what is the approach here? What should we do to get this question started? Anybody, just unmute
You would
yourself.
put the formula mass over molar mass.
So you'd put the, repeat what you just said, Jada.
You would write the formula mass over molar mass.
Exactly. So that's your formula, right? So that's where we'd start. So let me just put that in a text box here real quick, right? So moles is then going to be equal to our mass. So in this case, that's our given mass. And the units of that is in grams. And then we would divide that by our molar mass, as Jada rightfully said. So that's molar mass divided by, that's mass divided by molar mass, and the units of molar mass I'm going to put there just to make sure that you guys we're all on the same page, because you know I'm big about units, right? So that's the formula there for finding moles, right? All right, so let's see here. Let me get out of this text box. And so which one of you would want to complete this question for me? Anyone want to just do this for us so that we can keep it moving? So I need you guys to volunteer and interact with me. I'm here to guide you and help you through the problems, but I want you guys to like take the lead and make this as interactive as possible. So who wants to jump in and do this for me? Who wants to first find the molar mass for me? What's the molar mass of magnesium chloride? We're given the AR values there in the question. So what's the molar mass? Anybody can calculate that for me real quick?
I think it's 95.3.
95.3? Is that what it was? So that's 24.3 plus 35.5 times 2, right? So that's what? 71 plus, yeah, so 95.3. Perfect. Let me just get back my pencil here real quick so I can write that. First of all, let me move this. Let me move it over here. Can everybody still see that in the corner? I'll just leave it there. Can you guys see it? Is that okay?
Yes, miss.
Okay, so I'm gonna write it out now. And so our molar mass, so molar mass is, what did we say that number was? So we did, let me write it out so you see how we got it. So that's magnesium, that's the AR of magnesium. So that's the relative atomic mass of magnesium plus the relative atomic mass of chlorine, which is 35.5 times 2, right? And what's that number? That's 71, right? So that's 24.3 plus 71. So that's where we got our molar mass of 95.3, right? So once you get that molar mass then, and we have a given mass already, the molar mass is what? What's the units, guys? Gram per mole. Let's not forget our units. Units are important, so we got that. And we're given this mass of 38.2 grams of magnesium chloride. So that's how much from a mass perspective of magnesium chloride we have. And so to find the moles, then we're gonna say, using our formula that's in the corner, moles is equal to our mass that we're given. So that's 38.2 grams divided by
95.3.
5.3 grams from, okay, so what's that number now? When you divide out that
0.40 moles.
0.40 moles. So are we all clear on that? Do we all have that down in our heads? Because this is like the basics. This is like fundamental for what we're gonna do for the rest of today. So if you're all clear on that, give me a thumbs up so I know and I don't leave anybody behind, okay? Jada's give me a thumbs up. Aquila's give me a thumbs up. Beyonce says yes, miss in the chat. Who else? Who else is okay with this? I can't really see everybody's thumbs up. I can't really see that. Let me change my formatting so I can see everybody at the same time. Kalia? Kalia, am I pronouncing your name correctly or is it Kalia?
Yes, it's Kalia.
Kalia, okay. So I see your thumbs up and I see Beyonce's. Marianne, Akila Ross, I see you. Okay. All right, so I think we're all good on this, right? So let's keep it moving, guys. All right, so what we're gonna do next here is, let me clear this first. clear all my drawings. I'm gonna advance the slide now. So I think that this is where we had stopped last time. It's going then from moles to mass. So that formula is still the same. And I said last time, I want you guys to be comfortable committing that formula to memory so that, I mean, you're gonna write it every time, but so that I don't have to write it here every time and to help you to remember it on your own, okay? So right now we're doing a moles to mass, right? So we are given calcium nitrate is our compound of interest here. And so what mass of calcium nitrate is present in 0.030 moles of calcium nitrate? So what mass is in that amount? So who wants to take the lead on this one? Who wants to write on my screen and do this calculation for me? Let me see who is raising their hand here. Let me see if I see any hands, any volunteers. Let's see. Let me put this up at the top so I can see it easily. I don't see anybody raising their hand, you know. Nobody wants to do this one. Nobody's bold enough. Okay, I see Kalia is writing. I see Zanik and Jada's hand. Okay, so definitely keep those hands up and I will get to you. But Kalia has started writing, so let's see. So you want to find out 0.030 moles, what mass of calcium nitrate is in that, right? So Kalia, walk me through the steps that you would take to get to your answer. Tell me what you're thinking as you're writing.
Miss, you'd use the formula, you would say moles is equal to given mass over molar mass.
Okay, and what's your molar mass in this case? So generally
Miss, it would be 164.
It's 164. Okay, so how did you get that? You just use the formula, multiply the different components, right? Multiplied and
Yes,
added the
miss.
air values. Okay. So I'll start there actually, Kalia. Definitely write that out so we can all see. So write out your molar mass calculation first, right? And then build from there. So we're all seeing the build up and how
Miss,
it works.
it's kind of hard to write on this.
Oh, it's hard to write. Okay. Is it possible for you to use a text box or no?
Miss, I don't see the option for a text box.
Oh, okay. All right then. So let's just take that then that it's, or maybe I could write while you're writing actually. Let's see if I can write the molar mass. So keep doing what you're doing and I'll write the molar mass stuff, okay?
Okay, miss.
So molar mass, right? I just want to make sure that everybody is seeing that and how that looks. And guys, if this is too fundamental for you, if I'm going too basic for you, let me know. If you want the level of complexity to be up, let me know that as well, right? Because I don't want to be doing things with you that you're like, Miss, me already know that more want to see something hard or something different. If that's you, definitely let me know, right? Let me move this thing that I have in the middle of my screen. Let me clear what I just did. Clear my drawings. Okay, let me see. Let me move this up here. I just wanted to see what you guys were saying to me, but let me make it smaller. Oh no. Okay, I can see you guys there. Okay. All right. Don't worry about it. I'll go back to the slide. I know that I accidentally advanced it, but we can go back. Okay, so we're back. So let's see. Janelle, so they're dropping the answer in the chat. Okay, so 4.92. Jada said 4.92. Janelle says 4.8. Okay, so you just cross multiply, right? So are we all good on that? I was gonna write out the molar mass calculation, but it seems like you guys are all clear on that, so I don't need to do that. Or is there anyone who still wants to see how they got the 164 gram per mole? Is everyone clear on that, or do you want me to write it out nonetheless? Because I see that everybody got, well, the people who wrote in the chat already got the answer. So let us see. How are we with that? How are we all with this question? Are we good? Because I'm gonna like add a level of complexity, increase the level of complexity. So if you're lost here, say it now. Say it now before I add on to this. Is everybody good on this? Let's see. Okay, Akila. I hope I'm saying that right. Akila or Akila?
It's a Kaila, ma'am.
Akila. Okay, Akila. So Akila says that's good. Beyonce is giving thumbs up, so that's good. So I think we're all good here. So I'm gonna like up the level, right? So let's do that now. So let's advance the screen. All right. Okay, can you all see that? So now we're doing, we're finding the mass of product or reactant that we, okay. So we either, in these kinds of questions, you're either gonna be asked to find the mass of a product based on what they're giving you, or you have to find the mass of a reactant. So how much of X did I need to get Z? And if I have Z, how much of Y did I use to get Z, right? So this is like, now you're seeing everything in play, in context. We're looking at, we have to like be able to balance our equations. So we have our stoichiometric ratios, and then keep in mind what we know about the mole and how the mole is related to the stoichiometric coefficients, and then being able to go from mass to moles. Like this kind of a question is really putting everything together, right? And so I could go ahead and get you guys started on this by writing out the balance equation for you. So that's gonna be my starting point right now. So let me just do that for you, write out the balance equation. So when we're given a problem like this, our very first step is to write our balanced equation. So that's exactly what I'm gonna do right now. And so for this particular reaction, we are finding the maximum mass of iron, that's Fe, that's formed when iron 3 oxide, so that's the transition metal that we spoke about last time. We said iron is a transition metal, so it has different oxidation states. And that oxidation state is depicted by whatever we have in the parentheses, right? So in this particular case, we have iron, we have 3, right? Roman numeral 3 in parentheses. So we know the oxidation state of iron here is 3, plus 3, right? All right, so let me write out that equation for you real quick, and then I'll have somebody talk us through what needs to be done to get to the answer here, okay? So let me see where my pencil is, and then I'll just start writing this. Okay, I'm gonna use the stick brush. So the equation then for this is, let me write it down for you. Oh my gosh, I don't know why I'm all the way over here, but let's see. So it's Fe2O3 plus 3 carbon monoxide, right? That's our second compound. And that would then yield or give us 2 iron, 2 moles of iron, right? Because our stoichiometric coefficient represents our moles, how many moles of XYZ we have. So 2 Fe plus 3 CO2. Can you guys see that clearly? I don't like this thickness, but I think it can work. Can you guys all see that clearly? Say yes. Unmute yourself, and you can unmute yourself and say yes.
Yes, miss.
Okay, you can see that clearly. Okay, so what am I missing from this equation, guys? What I taught you guys that you should always have from
State
last time.
symbols.
All right, so the state symbols. Okay, so let me just put those in. So the Fe2O3 is a solid, right? Or carbon monoxide is a gas, right? So this is a gas, and we have to know what state we're in at all times, because depending on what state the compound is in, you'll get different products, right? And you see that as you go throughout your class, or maybe you even know of particular equations in which, or reactions in which that happens, right? If you have a solid in this case, you get something different. If you have it in the liquid form, you get a different answer. Gas, you get a different answer, so a different product. So that's why we have to write down our states, okay? So then the iron is gonna be a solid. So we have a liquid iron, solid iron that's being formed, and then carbon dioxide, of course, is a gas. So this is a gas, right? So are we all clear on this? So you can see my equation. It's not the cleanest looking, but the most important thing from this equation are our stoichiometry coefficients, right? That's what we need to pull out to see what ratio each what ratio our reactants and our products are in. And so that will guide us then as to what needs to be done, because that's where we're going to get the moles from. Okay, so the stoichiometric coefficient from these balanced equation are where you get your mole information from. So let me just write the coefficients here, the stoichiometric coefficients. Or does anybody want to read them out for me? Tell me what our stoichiometric coefficients are that we need to be paying attention to be able to successfully complete this problem. Is there anyone who can tell me that? What are our stoichiometric coefficients overall for the entire equation, and then what are our stoichiometric coefficients of interest for this particular problem? So if you know the answer, just go ahead and unmute yourself and tell me what that should be, okay? Let's see. Are you guys hearing me? Are you still with me? Are there any takers here? Let me see somebody saying in the chat. Shanae says she's still with us. Yes, that's great. Is anybody here? Is anybody want to take this on? What are our stoichiometric coefficients? I don't know if you guys are hearing me. Oh no. I don't know if you guys are hearing me. Can you hear me? Or is this the first time that you're seeing this kind of a question and you don't know, or you're not confident enough to shout out your answer? Okay, so let me help you out here. All right, so for the Fe2O3, guys, you notice that there's an imaginary one. So our stoichiometric coefficient there would be 1. So let me just write it out up here again. So we have 1 Fe2O3. So the ratio, we're doing the ratios, okay? To 3 carbon monoxide, right? And that yields then 2 Fe. So I'm just like writing ratios now, guys, right? Not the entire equation per se. And that's 3 carbon dioxide. So for shorthand, you just say 1 to 3. You just look at this. So you say 1 to 3. And then that gives us 2 and 3, right? So for this particular question, this question is asking you what is the maximum mass of iron formed. So how much iron is being formed when 798 grams of iron oxide. So this, let me get a pointer instead of this pen thing that I have going on here. Let me get my mouse back. Okay, yes, so there's my mouse. All right. So what's the maximum mass of iron? This Fe that's formed when 798 grams of iron oxide, so this Fe2O3 is reduced by excess carbon monoxide, right? So it's the iron oxide and the carbon monoxide that are reacting. It's a reduction reaction. So it's reducing that carbon, it's reducing that iron oxide. Remember I said the oxidation state of iron is 3 in this particular case, because we see that in the parentheses it's 3, and it's being reduced to Fe in this state, which is, what's the charge of iron in this state? So it's a reduction reaction, right? So what's our first step? Our very first step, as I've been teaching you guys, is to always find your molar mass of the thing of interest, right? So in this case, we're given the mass of iron oxide. So let's find the molar mass of iron oxide, and then we'll be able to find how many moles of iron oxide we have. And then now we'll apply our stoichiometric ratio to see how much iron we should be able to get from that. Okay, so is that clear for you guys? Let me write down the steps to take here. So Beyonce is saying she's hearing, but she doesn't quite know the answer. The ratios, what the way you said. Okay, okay. Oh yeah. So yeah, you can say the ratios, but generally they refer to it as a stoichiometric equation. So you would say the stoichiometric ratio. So that's that number that's before the compound. So yes, okay. So that's what I meant, Beyonce. I'm not quite sure how your teacher says it, but typically you refer to them as the stoichiometric coefficient, okay? So are we all good? Are we all clear on that and what needs to be done now? Let me see if I can see your thumbs up or your just you and what you're doing. Let's see what you guys are saying here. Beyonce says that that's okay. Is everybody comfortable with this? What I just did, how I just wrote that out? Let me know. Give me a thumbs up, okay? That's our way of communicating. That's my way of knowing that I'm not leaving anybody behind. I don't want any of you to be left behind. Janelle says she's lost. Aquila says to some extent. Marianne says, yes, miss. All right, so Marianne, do you want to break it down for the rest of us? Britannia said, I don't understand the ratio. Okay, let me see if I can clarify the ratio thing a little bit more. I really don't like the thick thing that I have, the thick writing. I want to get rid of that. Okay, so I just got rid of everything, guys. I'm gonna write again, right? So essentially what I'm writing is just the stoichiometric equation or the balance equation. Let me just stop using stoichiometry because I don't know if that's confusing to people. I don't know if your teachers said it like that. So let me not say that. So I'm just gonna write out the stoichiometric equation again. I don't want this thick line. I want a thin line, so you guys can see it. Or maybe I should just use a text box and not worry about the subscripts. That's what I'm gonna do. All right, so I'm gonna write out what I'm writing now, guys, is the balanced equation, right? When you get a problem of this caliber, where it's asking you to find the mass of a product or mass of a reagent, you have to have a balanced equation. It's not like the one where we were just doing a while ago, when we were just going from mass to moles or moles to mass. For this kind of problem, you need to have a balanced equation. So that's generally the first step, I would say, right? Write the balance equation that goes along with the transformation or the equation or the reaction that they're asking you about, right? And in this case, this is our equation. Our equation is Fe. So I'm not going to write a subscript 2, but you know that the 2 should be a subscript, right? So Fe2 O3 plus carbon monoxide. So it's 3 moles of carbon monoxide. When we balance that equation, we're going to get a 3 in the front. So that's that 3 that you see there. And that's going to get us, let me write this like that. So that's going to give us 2 iron. So that's 2 moles of iron, essentially is what that's saying, guys. And then 3 moles of carbon dioxide, right? And of course, you know, you always have to have your state symbols. So let me just do that for completeness. I don't want you guys to get into the habit of not writing state symbols because it's very, very important. So let me do that myself. Hopefully I can get that done. Let me go here. So let me see like this. So are you guys clear as to why I'm writing the equation and why that's our starting point? Like if you don't know the equation, you're not going to be able to solve this, period, right? Because you need to use ratios to do it. So that's why I'm writing this. So if the people who said that they weren't really clear as to what was going on, I hope that this is a little bit clearer to you as to why I'm doing what I'm doing, okay? So that's that. And so our stoichiometric ratio, or the coefficient, the moles, essentially, I can say that in many different ways. The stoichiometric coefficient, the mole ratio, or the moles of this particular species are what I have in front of it. So this is an imaginary 1, this is a 3, this is a 2, this is a 3, right? So it's important to know those ratios because we're going to need them as we proceed with the calculation and as we just work through this problem. So are we all clear here? Give me a thumbs up to let me know if you know what I'm talking about when I say ratio now. Like mole ratio, stoichiometric coefficient, the numbers that you use to balance the equation is what I'm talking about. Like those are your stoichiometric coefficients, okay? All right, I hope that's clear. If it's not, let me know. Still let me know. And if I'm moving too slow for your liking, also let me know, okay? I just want to make sure that we're all on the same page going forward. All right, so who wants to calculate the molar mass of iron oxide for me? So somebody calculate the molar mass of Fe2O3 and let me know. And then somebody calculate the number of moles of Fe2O3 that we have. Because we're able to do that now, right? We know that we have 798 grams of Fe2O3. And if we find the molar mass of it, then we'll know how many moles of it we have, and then we can proceed from there. Okay? So can anybody find the molar mass for me real quick? Drop that in the chat or unmute yourself and let me know. And then we'll find the number of moles, and then we'll keep it moving. So that's how we're going to approach this problem. You balance the equation first, right? Then you find out the number of moles of product or number of moles of reactant that you have. And then using these ratios, you can find out, oh, if I have X, then that means that I'm going to produce Z. If I have Z, then that means I must have started with X. So that's kind of how we're going to approach this. And that's a general approach when you're solving these kinds of problems. So is that any clearer now to you guys? Let me know. Where's the oxygen? So the oxygen, did I have an oxygen before? So the oxygen is this, right? So the oxygen is already combined in a compound here. It doesn't stand alone for this particular problem, right? The oxygen in this problem is embedded with our iron oxide or carbon monoxide or carbon dioxide. So that's where the oxygens are for this particular problem. So Abigail says 160 is the molar mass, okay. So if our molar mass is 160, let me just write that real quick so you guys can see. So again, guys, we're using our formula that I said you should know, right? That moles is equal to our mass divided by our molar mass, right? And Abigail just says our molar mass is 160. That's 160 grams per mole, right? Don't forget your units. And we're given that the mass of iron oxide, let's memorize this first. Moles of iron oxide. So where do we know what moles we're talking about? We're talking about the moles of iron oxide. That's what we're finding because that's what the mass is that we're given. We're given the mass of iron oxide, and we want to convert that to moles because moles is the currency that we use, right? Moles is what the balanced equations are based on. Right? So that's why we know you give us mass. Well, we have to get moles because moles is the language that we speak, right? All right. So the moles of iron oxide is equal to the mass divided by the molar mass. And so then that's going to be 796 grams divided by 160 grams per mole. So what's that answer, guys? Real quick. What's the number of moles of iron that I have? Tell me that based on that calculation or based on that formula. So just shout that out. If you're unmuted, unmute yourself and let me know what that number of moles is, and then we'll keep moving from there, okay? But we need our number of moles to be able to move on. If we don't have our number of moles, then we can't do anything. That's our currency. That's the language that we speak. That's the money that we use. Like, just tell me what the number of moles is, and then we'll keep it pushing. All right? So Abigail says it's 4.98. That's our number of moles. Okay, so let us round that up to 5. Right, let's just round that up to 5. So I'm just gonna write that real quick. 5. So Abigail says it's 5. So, oh wow, why is my pencil not writing? Let me see if I can get the pencil to write 5. Okay. But in the meantime, while I get my pencil to write at 5, can anybody tell me what my next step is then gonna be? I need you guys to be interactive. I know you're not sleepy at this hour, certainly not. So why aren't you guys talking to me so I can know that you're following along nicely and that it's all making sense? Because what I don't want is for you to come here and be lost. We don't want that. This is a session for clarity, a session in which you understand all the things, right? So that you will ace your exam. So like if you don't, all right, here's my pencil again. Hallelujah. Oh my gosh. 5 moles of Fe2O3, that's what we have. So we have 5 moles of Fe2O3. What's our next step? Anybody? So let me just write our stoichiometric coefficients here again. So we have 1 to 3. That's our ratio of Fe2O3 to carbon monoxide. And then on the product side, we have 2 moles of iron that's being formed, and we have 3 moles of carbon dioxide that's formed as well as a result of this reduction that takes place of Fe2O3 by excess carbon monoxide. And guys, whenever you see excess, whenever you see this word excess, don't let it throw you off. Excess just means that you have enough. You have more than enough for the reaction to proceed. Nothing is going to limit it. Nothing is going to stop it. You have more than enough for this, in this particular case, for the reduction of iron oxide to take place. Okay? So that's just what excess means, right? All right. So now Abigail just told us that we have 5 moles of Fe2O3, and she got that from this fact that they say we have 798 grams, or molar mass is 160. So we divide 798 by 160, we get 5 moles, roughly. So we have 5 moles of iron oxide. That's that 5 moles that's going to get reduced by that excess carbon monoxide. And that's, we're trying to find out how much iron are we going to get from that, right? And so immediately, based on these stoichiometric coefficients, we can see that the ratio of iron, Fe2O3, to iron is 1 to 2, right? So for every 1 mole of iron oxide that we reduce, we're going to get 2 moles of iron. Is everybody seeing that? So that's just, let me write down what they represent. So that's Fe2O3. My pencil is, I'm really struggling with this pencil, guys. Bear with me. I don't know what's going on today with it, but that's Fe, right? So it's 1 to 2. And we got that from our stoichiometric coefficients, right? So here I had the 1 to 3, and then 2 to 3. So for every 1 mole of Fe2O3 that gets reduced, we're gonna get 2 moles of iron. And we want to find, that's what we want to find, right? The maximum mass of iron that gets formed when iron oxide is reduced, right? All right. So can somebody tell me then, based on that, the fact that we have a 1 to 2 ratio, if we reduce 1 mole, we're going to get 2 moles of iron. If we reduce 5 moles of iron oxide, how many moles of iron are we then going to get? Based on the fact that what was that?
10.
Exactly. Who said that? I can't see. Who said that?
Dawson.
Who's that?
Dawson.
Dawson. Okay. So then continuing with that, Dawson, if we got 10 moles of iron, then what mass of iron is 10 moles? So you see where I'm going? Now you have to convert that moles to mass. So that's why we did those building blocks, so that now in this big picture question, you can then get to the answer that's needed. So you just said, we're gonna then get 10 moles of iron, right? Because we have a 1 to 2 ratio. So if we have 10 moles of iron, how much mass? What mass is that?
$558 grams.
Exactly. That's exactly right. All right. I want to write that down on my screen so people can see that number. And can you tell us how you get that? Do you want to write on my screen for me?
I can write, but I can say that because the formula is molar mass times mole, and since we got 10 moles, you would multiply it by the molar mass, which is 55.8, and then you would get 558 grams.
Exactly. That is exactly right. Thank you so much for that, Dawson. Thank you for that contribution. Is everybody clear on that, or do you want some further explanation? If it is that you do, definitely let me know what that further explanation might look like for you. Okay, so let's see. I'm looking at the chat now. Chanel was saying 10, so Chanel got that 10 moles. And then Britannia, what specifically? Okay, I see Britannia and Aquila. Let me not mess up your name. Aquila is saying that further explanation is needed. Britannia says she doesn't understand how we get the 10. Okay, so let me just break this down a little bit more. Okay, so let me just do this. See how better I can do this. Why did I erase the equation? Write it again. All right, I'm gonna write it really quick. Hopefully my pencil comes. Okay, here we go. So we have Fe2O3, and that gets reduced by carbon monoxide, right? So that's 3 moles of carbon monoxide. And then from that, we're gonna get 2 moles of iron. I don't know why I'm not writing my state symbols. I don't want you guys to get in that bad habit. So let me do it. Right, this is a solid as well. And then we get carbon dioxide gas as well. And we get 3 moles of that. So let me just make sure that we have that. Okay, so this is our starting point, guys. And what I'm saying is moles is a language that we're speaking in chemistry. That is our currency, moles, right? So when we balance an equation and we have a balanced equation, what the balanced equation is telling us is the proportion as far as moles go that our reactants are reacting with each other to then give us our products, right? So our reactants are on our left, our products are on our right. So in this particular case, then what we see is that we have 1 mole of iron oxide, right? And that is being reduced by 3 moles of carbon monoxide. And that's gonna get us 2 moles of iron, right? And also 3 moles of carbon dioxide. So are we all on that same page? So give me a thumbs up, guys. You have to interact with me here so I make sure you're understanding and you're not getting lost. So that's our first step, or first basal level of understanding here. So I see those thumbs up. Thank you for that. So I'm seeing those thumbs up. All right, so that's great, right? So just to summarize, our balance equation tells us the ratio in which, the mole ratio in which things are reacting and then things are being produced. All right, so we're all clear there. Annie, go ahead and ask your question. I see that you just raised your hand. Do you have a question, Annie? All right, maybe you raised your hand accidentally. I'll just take it as that then, because I don't see you asking. Let's see. Julissa, yes. So the recording, so this is streaming live on YouTube. So you'll be able to watch back the replay on YouTube. Okay, so if you joined us late or whatever the case may be, yeah, you'll see it on YouTube. So just make sure you go and subscribe so you can get notified and you'll be able to see that, watch it back at your own time, and make sure you're comfortable with these concepts. Okay. All right. So where were we? So we have our start, we have the numbers that are before these reactants and also before these products, and that is essentially our moles, guys. Think of that as your moles, right? So in the general case, the standard case, the moles are as written here, right? So okay, so for the standard case, what I'm saying is that you will always have, for this particular reaction, for this reduction that's taking place, you're always gonna have, let me just use a text box because that's easier. You're always gonna have 1 mole of Fe 2O3 that's getting reduced, right, by 3 moles of carbon monoxide to get 2 moles of iron, that's Fe, and 3 moles of carbon dioxide, right? So is that all clear now to you guys? So that's essentially what's happening there in this reaction. If I were to write out the reaction, the balanced equation in words, that's how I would write it out. So that's what I just wrote out, okay? All right. So we know that in the standard case for the balance equation, for the balance reaction, 1 mole of iron oxide is gonna get us 2 moles of Fe, 2 moles of iron, right? The question is asking us what's the maximum mass of iron that we're gonna get when 798 grams of iron oxide is reduced, right? So they are telling us how much they are actually giving us, right? In the standard case, 1 mole of iron oxide is going to get us 2 moles of iron. They're giving us a mass. They're saying, okay, so this is how much mass of iron oxide you have. So what we have to do is find out how many moles of iron oxide is that. They give us a mass. We have to convert that to moles because our currency is moles. And we know that 1 mole will always get us 1 mole of Fe2O3 will always get us 2 moles of iron. So our job is then to say, okay, you're telling me that you're giving me 798 grams of iron oxide. So I have to find out how many moles that is. So then I know how many moles of iron oxide I have. And based on the fact that I know that 1 mole of iron oxide will always give me 2 moles of iron, I can then find out how many moles of iron I have, right? And once I find out how many moles of iron I have, then I can convert that moles of iron to a mass of iron. So does that work? Does that make sense to you guys? So that's essentially what we're doing or what we just did. So tell me if that's clear for you or if there's any clarity that has been added based on that explanation. If not, please let me know where you're not getting, and then I'll try an alternate explanation. But that's essentially what we're doing, right? And then all that remains is then to do that from a mathematical standpoint and to do your actual calculations and crunch your numbers. So plug in your numbers in your calculator and see what that would come out to be. So I'm here for you guys. I want you to understand. So if you don't understand, ask again. Ask a question again so I can see if you understand, right? Or say it in the chat, Miss, I still don't understand. Say it again. Come again. Miss, oh, you got the 3 CO. Okay, so that's just the balance equation. And in most cases, you'll be given the balance equation or you'll be asked to do it based on your knowledge or your understanding of chemistry, right? So this is just the balance equation that they give us. This is an equation for the reduction of iron oxide, right? So I think I just had a little bit of a Wi-Fi issue, guys. I hope that doesn't persist because I want to finish this lesson with you guys. And I really, I think my work went away, what I was just doing, but I'm here now, so I can talk to you guys. So Where were we, guys? Where were we? Where were we just now? Can anybody recap me? Fill me in? Fill us all in? Where were we just now? I want you guys to interact with me, you know. This is not just
Ma'am,
for...
I think it's a bit after the explanation. I'm not too sure.
What was that?
I think you were speaking about the explanation. After you did the explanation, you're going on to speak about something else.
Okay. So we are at the point of for the stoichiometric ratios, right? And saying what we then need to do to build on to get this final answer. So let me just write out those again. Right. I'm just going to write out the ratios. I'm not going to write out the full equation. Somebody was asking where I got the equation from, and I was saying that in some cases you'll be given the equation, and in some cases you'll be expected to formulate that equation on your own, because you now as a student can sit down and be like, okay, this is how this reaction is going to work, and then you balance it and you're good. But you always have to have a balanced equation, and if it's not balanced, you have to balance it, because that's where you're going to get your ratios from. Okay, and let me just write out the ratios again here. I'm going to write out the ratios of interest for us here, and that's 1 to 2. Right? That's a 1 to 2 ratio. Like that's our ratio that governs this entire question, is that 1 to 2 ratio. Beyonce said, misunderstand, but did you times the 55 by 10? Yes, exactly, Beyonce. You have to the 798, right? So I'm gonna show you what's what here, where each species fall, right? So let me show that. So Beyonce was asking why times the 55.8 times 10 as opposed to the 798 times 10. So essentially she's talking about how we calculated the mass of iron. Yeah, so the mass of iron, so that 55.8 is what? Where do we get that 55.8? What's the molar mass of iron, guys? Because iron is what we're interested in, you know. What's the molar mass of iron? Anybody?
$55.8.
Exactly. So that's what we multiply. That's what we multiply by 10, right? Because mass is equal to your moles times your molar mass. So I'm gonna write that and show you like a triangle, that equation. Because all we're doing is like we're just messing around with the equation, you know, in the grand scheme of things, right? Of course, we have to know our ratios and our stoichiometric coefficients and what we actually are being asked to find. But essentially, with this equation that I showed you, like that's the equation that you have to remember for mole concept. Like you have to remember it. I'm gonna draw it like a pyramid or like a triangle so you can see how you're having to go between those, all those three things: moles, mass, molar mass, situation. Molar mass is standard, right? You always be able to find the molar mass because you have your periodic table and that's not changing. But what's changing is the mass that they're giving you and the number of moles then that's related to that given mass, okay? So those are the things that you're always gonna be asked to do. Okay. 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 So our mole ratio of interest is 1 to 2, right? So one mole of Fe2O3 is always gonna get us 2 moles of iron, right? And that's what we want to find. We want to find out the mass of iron that we're gonna get from 798 grams of iron oxide. So on this side, so we have 798. We have 798 grams of iron oxide. And then we have to convert that to moles, right? So mass to moles we have to do. And mass to moles, this is what I said I was going to write down for you guys. So our mass, let me put the mass. So mass is always going to be equal to moles times molar mass. And then if you use the units, you see that your units always have to work out too. So mass that we're trying to find is always going to be our moles times the molar mass of that particular thing that we're trying to find. So the molar mass of iron is what we're going to need eventually. But I'm just showing you this equation here of moles is, so you have your moles, that's a unit, right? And then molar mass is gram per mole. Right? So when I multiply those two guys, the moles are gonna cancel, and I'm gonna end up with just grams, however many grams of stuff, right? All right, so keep that in mind, right? So similarly now, let's go back to here. So we have 798 grams of Fe2O3. But as I said, moles is what we speak. Moles is our language. We have to put this in moles because that's what we're gonna use for the stoichiometric from the equation, right? So to find that number of moles, then we're gonna do 798 grams of Fe2O3 divided by the molar mass of Fe2O3. And the molar mass of Fe2O3, we said, I think Jada said that was 160. She did that calculation and that came out to be 160. And so we're going to divide 798 by 160, right? 798 by 160, and that's where we got that 5, right? So see it here now, 798 grams divided by what? 160 grams per mole. Those grams are going to cancel. Our mole is going to come up top. And so we get 5 roughly, 5 moles of Fe2O3. So we have 5 moles of Fe2O3, right? So that's what we have, guys. Based on the 798 that they gave us, we know that we have 5 moles of Fe2O3 starting out. Right? Is that clear? Give me a thumbs up so I see that we're all there. Because then this is where we're using ratios, right? So Kayla says thumbs up. Who else is saying thumbs up? Let me know that you guys are all getting this. And if you're not, I'm looking at the chat. If you're not, say something in the chat, okay? So that's where we are, right? So we have 5 moles of Fe2O3. That's what we are given, right? Now, if we go back up top, we see that the ratio for every 1 mole of Fe2O3, we're gonna get 2 moles of iron. Every time. Like that's how it is. That's how the balance equation tell us. If we have 1 mole of Fe2O3, we're gonna get 2 moles of iron. So if we have 5 moles of Fe2O3, we're always gonna get 2 times that amount. So if we have 5 moles of Fe2O3, we're gonna get 10 moles of iron. Do you guys see that? That's the next step. 1 to 2. So we have 1, we get 2. We have 5, we get 10. So we're gonna get 10 moles of iron. Do you guys see that? That we get 10 moles of iron, and you see how I got there? Yeah, you see that? I need everybody to answer. I don't want anybody being silent, anybody being left behind, because I'm gonna take it that you don't understand if you don't answer. And I want every single one of you who are in this meeting today to understand this, because this is like foundational stuff. Right? Okay, so Beyonce says, yes, miss. So I get that from her. That's okay. So we have 10 moles of iron, right? 10 moles of iron. So then what remains then is to convert that 10 moles of iron to mass. And we're going to use a formula that I wrote on this left-hand side. So this is our formula. I should have put it in a different color, but this is our formula, guys, right? So now we say we have 10 moles of iron, right? So we got that from, we say 5 moles is gonna get us 10 moles because of that ratio. Just so we're all clear, right? So this is a 1 to 2 ratio from up top, right? So it's always gonna be double. I have 5, all right, 10 may I get. May I have 1, may I get 2. So now I get my 10, I have 10 moles, right? And applying this equation, then we have to find mass.
Miss, you're muted.
Okay, I am back, guys. The internet is really fighting me today, but we will persevere. It will work today. Um, so where was I? I was saying I was at the last step, guys. So the number of moles, we're converting 10 moles to mass. So, and I was asking somebody to tell me what the molar mass of iron is, because that's what we're trying to find, the maximum mass of iron. And to get that, we need to multiply the number of moles times the molar mass. So that kind of gets to what Beyonce was asking me. She was asking me why we multiply the 10 by 55.8, which is our molar mass. Our answer is, the answer that we got was 550, 58 grams, right? So I just kind of give you guys the answer. I just said what it would be, or what that is, right? So is that clear now, guys? Is that all clear, or you want further explanation on that? Let me know. And then if not, we're going to move on to a problem using Avogadro's law, because it's the other type of problem. Actually, yeah, we'll see if that's what comes up next. But yeah, that's kind of where we are. So is that, are we clear on that?
Yes, miss.
Okay, so Kayla says yes, but I want to hear from everybody else too. Thumbs up, thumbs up, thumbs up, thumbs up, thumbs down, sad face. Like all those things are welcomed here because you're learning, right? And I want you to learn. I want you to get it. So if you don't, let me know, right? Because somebody might have the same question as you, but they're afraid to ask. But I'm telling you, you don't be afraid here. Like if you're afraid in your class, don't be afraid here. This is not a place to be afraid. This is a place to learn, right? So, all right, so Deshanel said clear. Britannia said clear. Bianca said yes. All right, so guys, that helped? Did that help? It seems as though that clarification helped. So it helped? Give me a thumbs up if that helped. And then we will keep it moving. All right, so that clarification, oh my, I love to see those stuff. Yes. All right, let's go. All right, let's go. All right, so let's do the next problem. And I want you guys to be interacting with me. I need you guys to be interacting with me. All right, so the next question is up now. So we're finding the excess reagent. I remember a while ago I was telling you that when you see excess, don't worry, don't get scared. If something is in excess, it means that that's great, right? It means that you have enough to get your reaction done and to get your reaction go to completion. Nothing is gonna stop it, right? So the next type of mole concept problem is finding the excess reagent. They'll be like, okay, what's in excess? Like what reagent is in excess? What do I have extra of? And what, so then when the reaction completes, how much will be left over? Because sometimes you want to know that, you know, when you're doing a reaction, you want to know if you're going to have enough, because you don't want to be doing an expensive synthesis. You're synthesizing some drugs or something, and you don't have enough reagent. Right, that will be a problem. You want to have enough. And so you want to be able to then do these kind of calculations to see what would be in excess, what would be left over. And also you have to make sure that, so then you as a person, as the chemist who is in a lab, making this intricate molecule to save the world, to cure cancer, you know that you're not going to be the person who messes up the calculation. You want to know if you're in excess or if you're limiting, right? So that's what this kind of problem, this group of problem is really testing your ability to see that. So let's jump into it then. All right, so this is what we're working with, right? So in this example, 4.60 grams of sodium is reacted with sulfur to form sodium sulfide, which is Na2S. So they're asking you which reactant is in excess. So they're saying, oh, we're giving you two masses of our reagents and we're telling you what's formed. Which one of these do we have in excess? So, all right, so this is how we approach this kind of problem. All right, so of course, again, guys, our first step is always to write the balanced equation, right? So let's write the balanced equation here. And so they tell us what's reacting. They say we have sodium and we have sulfur. So we can write, and they tell us what the formula is of our product, so we can write that, right? So let me just write that for you real quick. And if anybody knows or has an idea as to how they would approach this, let me know, and then I'll just like let you speak and share that with your colleagues, okay? So sodium is Na, And that's what's reacting with sulfur, which is S, right? So yeah, so then we're gonna get sodium Na2, sodium sulfide. So that's Na2S, and it told us that. Guys, what am I missing from my equation? Help me. Help me to.
Two on the sodium, two at sodium.
Okay,
the
so
left.
I just put it out there. And then what am I missing? I'm missing my state symbols, right? So sodium is a metal, so we just say that's in a solid state. I think sulfur in this case would be a solid, and sodium sulfide. Sodium sulfide, I think that would be, let's say that's a solid. Okay, all right. So which reactant is in excess, right? We have our balance equation, we have our state symbols, we have everything there, right? And so we have to find our, which is in excess, then we have to convert. Remember I said your currency, the language that we speak is moles, right? So if you're giving me mass and I have a balance equation that's in terms of moles, I'm gonna have to convert my reactants from mass to moles, right? So can somebody do those for me? One person do it for sodium and one person do it for sulfur, and drop that in the chat and tell me what that number is in moles, because that's our starting point. We have our balance equation, great. And that tells us our expectation or what we need from a mole standpoint. And now we're gonna see if what they're giving us is matching with that. And if it doesn't match, then we can say what's excess and what's limiting. So that's your general thought process for this kind of a problem where it's like excess to reagent, right? So can somebody tell me, convert 4.60 grams of sodium to moles? How many moles is that? And how many moles is 3.52 grams of sulfur? So those are what I need you guys to plug in your calculator and tell me those numbers real quick. And then we'll be able to figure out what's in excess versus what's limiting, okay? So do that for me real quick, okay? Who is doing it? If you're doing it, indicate that for me so I know that you're calculating it for us. And let me know what you're calculating, okay? So unmute yourself and tell me what you're calculating the moles of. Okay? Let's see here. Is anybody calculating it? Can you see me or am I frozen? Let me see. Chanel, can you hear me?
Yes, miss.
Okay. Is anybody calculating this for us? Or was my instruction not clear?
Miss, what exactly are we calculating?
So you're calculating remember I said our language that we speak is moles, right? They're giving us mass, but we don't want no mass. We want to find the amount of moles. So they're giving you mass, you have to convert that to moles. So find the moles of sodium that we have. So from that 4.60 grams, convert that to moles.
Miss, I found the moles.
Okay, so for which one? Sodium?
Yes, miss, for sodium.
Okay,
Miss,
so how many moles is that?
Miss, I divided 4.60 by 23 and I got 0.2 moles.
Okay, 0.2 moles. Okay, and who was doing the one for sulfur? She said it's 0.2, so let me write that. Is anybody doing the one for sulfur? Kayla, are you also doing that? Because I don't hear anybody else.
Miss, is it 0.11? Is it?
So you get 0.11? All
Yes,
right.
I got that as well.
Okay, and so that's 0.2 and 0.11. Is that correct?
Yes, miss.
Okay, so let me get my box and I'll write out how we're thinking about this one. All right, so let me put this box here. All right. So Kayla says 0.2 moles of sodium. And then Aquila, was that you who said we have 0.11
Yes, miss. It was me.
moles of sulfur? All right, guys. So all right, so look at that now. And then from our balanced equation, we know that the way in which sodium and sulfur react is always in a 2-to-1 combination, right? So look at this now. 2 moles of sodium reacts based on that balanced equation, you know, that's where we're getting that, reacts with 1 mole of sulfur, right? All right. So based on what we have, right? Based on what you guys just calculated and told me, what is in excess and what is limiting? So based on that stoichiometric equation, 2 moles of sodium reacts with 1 mole of sulfur. That's what we always needed to be in that ratio. Based on what you guys just told me, you know, what do we have? What kind of ratio do we have? Like what ratio of sodium to sulfur do we have? We need a 2-to-1, and that's okay. That's like just enough, just right for things to proceed, for the reaction to go to completion, for everything to work. You told me that we have 0.2 moles of sodium and 0.11 moles of sulfur. Is that a 2-to-1 ratio? Is the ratio off? Is something more than it needs to be? Like that's what we mean when we say something is in excess. So which of those two is in excess based on the fact that you know that the ratio that we actually need is a 2-to-1 ratio of sodium to sulfur? Is it clear what I'm asking you guys? Let me know.
Miss, would we say that sodium is in excess?
So why would you say sodium is in excess? Explain to me your logic.
Miss, because 0.2 would have been greater than the 0.11.
It's greater than 0.11, but in terms of the number of moles that we need, right? Does that work out? Does that work out? Right? Because we always need to have, essentially, you know, what we always need to have. I can't tell who was speaking just now. Who was speaking just now?
Deschanel.
Chanel. So based on our mole ratio, we're always going to need to have at least 2 times more than we always going to need to have at least 2 times more than what we have for sulfur. So look at it like this. If I have 0.11 moles of sulfur, right? At the basic level, I need 0.22 moles of sodium. Because I always am going to need at minimum 2 times as much as whatever sulfur I have. Do you see that logic?
Yes, miss.
So then what's in excess in this particular case?
Is it a 0.11?
So it would be the 0.11, right? And so that would be sulfur. Sulfur is in excess, right? And so if we find out by how much, we can then extend this and find out by how much, right? So do you guys see that? Or how I kind of got that? That kind of logic? To completely react with 0.2 moles, we would need, or you can look at it the other way too. I don't want to confuse you guys, so let me see if you get that one first. Do you understand how I arrived at the fact that we don't have enough sodium? What we have, in fact, is more sulfur than sodium, or that we would need for this reaction to proceed. Are you guys clear on that? Because we can do it another way too. You know, I can show you another way of knowing what is in excess, but that's one approach. So if you're clear on that, give me a thumbs up. Let's see. Jada says sulfur is in excess. Britannia says yes, miss, that's clear. Aquila says yes. Kayla says yes. Missy Howell says yes. I don't see any other thumbs up. I hope you guys are still there. Even though you're not giving a thumbs up, I hope you're there. Who was saying something just now?
Sorry, you're going to show us the next approach?
Yes, I can show you the next approach. It's essentially the same. It's just looking at it from the other way, right? All right. So we said that our mole ratio is 2 to 1. At a basic level, we need 2 moles of sodium to react with 1 mole of sulfur, right? Based on the calculations that that you guys did, you said you have 0.2 moles of sodium and 0.11 moles of sulfur, right? All right. So if we have 0.2 moles of sodium, in theory, based on the balance equation, we'd only need half of that. We only need half of that for our reaction to proceed because it's that same that 2 to 1 ratio, right? So we only need half of that amount in terms of how many sulfur we would need. So if I have 0.2 moles of sodium, I only need 0.1 moles, like 0.1 moles of sulfur, because it's 2 to 1. It's half of it, right? Does everybody follow that logic? I'd only need 0.1 moles of sulfur because that's half the amount, right? So guys, these little significant figures matter, you know, because like it's literally, I need 0.1, but I have 0.11. So I have extra, right? How much extra do I have, right? Because in theory, I only need 0.1 because that's half of the amount of sodium. But I have extra because I have 0.11. So if I want to find out how much extra I have, I'll say 0.11 minus 0.10, because 0.10 is what I need to satisfy the stoichiometry coefficient, right? Is everybody clear on that? Are you following my words? Deschanel said that's clear. Miss Wells, Beyonce said that's clear. Aquila says that's clear. All right, is that clear to all of you guys? Britannia, Anique, Marianne, are you following that? Kalia, is that all clear? So I know that the sulfur is in excess. Anique says yes, that's clear to her. Kalia says yes. All right. So I just want to make sure you guys are getting things. I don't want to rush and pile on without you getting this, because I don't want you to be left behind. Like if you're here for a reason, you want to learn, you want things clarified. So I don't want you to be lost. So seems like we're all on the same page. So I'm going to keep it moving. And then to our next problem. Let's see if that's Avogadro's. As a matter of fact, let me find an Avogadro's law one for you guys. So let me stop this and go to my PowerPoint and specifically give you Avogadro's law one, because we haven't done that at all. All right, so let's do that. What time is it? All right, we have 8 minutes left. We have 8 minutes left, so let's see how far we can get. Let's try this Avogadro's law one. This is our first one, or basic one, right? Then we're gonna add on a level of complexity for these kinds of problems. So are you guys seeing that? I think you are. So let me share that problem. All right, so that's our Avogadro's law problem, right? So it's asking us to calculate the volume of 3.08 grams of carbon dioxide at STP. Can somebody tell me what's STP again, and everything that we need to know about STP for the intents and purposes of this problem? What is STP, and how does STP factor in?
And pressure.
It's standard temperature and pressure. And so what's that, Jada? What's that temperature and what's that pressure? And then how does that relate to our moles? You remember that from last time? What I
Yes,
said?
the
22.4.
So it's 22.4 dm cube is how
Okay.
many, it's the volume that 1 mole of gas would occupy. So that's exactly right, Kalia. And then in terms of the actual conditions though, what are the conditions? What did I say the temperature was and the pressure was for STP?
Miss, the temperature is 0 degrees and the pressure is 760.
Millimeter of mercury, right? So you always want to give your units, okay? Always give your units so I know what you're talking about, okay? All right. So here we have a problem where it's asking us to calculate the volume of 3.08 grams of carbon dioxide at STP, right? So when you see a problem like this, what would you think you need to do first to be able to proceed? Because we're talking about molar volumes, we're talking about moles, and we're talking about how 1 mole of gas occupies 22.4 dm cube at STP. So when you look at this problem, where might you begin? Where might you begin? You have a mass of 3.08 grams. And I said, guys, we don't speak in mass. Mass is not our language. We speak in moles, right? For the most part, we speak in moles. And so the first thing that you need to do is then, what do you need to do here? The first thing that you calculate the moles, right? So how would you go about calculating the number of moles then?
Mass over molar mass, so it's say 3.08 grams over carbon dioxide, which is 12 plus 6 times 2, so 12 plus 32. That's how much?
44, right?
44, and then you get the moles, you times it by 24.4, and you get the volume, and the unit should be in dm cube.
All right, boom. All right, so did you do that already? Did you calculate it for yourself already?
No, miss, I just look at the question and just do some jottings.
All right, so that's exactly right. So let me write that out. All right, so the first thing that we want to do is convert mass to moles, right? So in a sense, what you're gonna do is convert 3.08 grams to moles. So that would be 3.08 grams divided by 44 grams per, oh, so let me put in a bracket. So, well, you know that's the unit that I'm writing. So what's that? Can somebody tell me that math real quick?
0.07.
All right. 0.07 moles of CO2 is what we have, right? All right. So then our next step would then be to say, okay, based, let me write that out. So we're all seeing that. So based on Avogadro's law, 1 mole of gas at STP occupies a volume of 22.4 dm cubed, right? Cubed. All right. So since we have 0.07 moles, it is gonna occupy less than that 22.4, right? Because we don't have 1 mole. 1 mole is a take of 22.4 dm cube. So we're gonna have less, we're gonna occupy less than that. But how much is that? So since 1 mole takes up 22.4, so this is all just ratios, guys. So if you're good with ratios, you should be able to do these, okay? So 1 mole takes up 22.4, so 0.07 moles will take up X. So you're cross multiplying essentially. So that's how we end up with our answer. Miss X, I can't even see that, so I know you guys can see that. So X is equal to 0.07 moles times 22.4 dm cubed, and then that whole thing is divided by 1 mole. So that's how the mole is gonna cancel out, and you're gonna get, what's that number? Dun, dun, dun. What's the number? What's the
Miss
answer?
1.6.
What's the answer? 1.6?
Yes, Miss.
And what's your unit?
Miss DM cube.
Okay, perfect. All right, let me pull that up. I'm gonna pull it up. I'm gonna move this up on the screen so you guys can see it. Okay. All right. So that's how we work that out. That's kind of our steps. Can you all see that? Is that clear? Are there any questions on this? Anik says that's great. Excellent. Let me see who else is saying that's good for them. Jada says it's clear. Who else? Everybody, I need to hear from all of you before the session is over. We have a minute to go, and I want to hear from you how this was for you today. How was this for you guys today? You can unmute and tell me. You can type in the chat. Just let me know how this was. I want to know if it's helpful, if it's moving the needle in your knowledge / your understanding of chemistry, right? So let me know. We have 1 minute to go. We're not gonna be able to squeeze in anything else today. Is either we pick up on this one next time, or I can give you some questions to work out throughout the week and we'll be communicating on those. And I'm also gonna put a question on our Instagram. I did that last week and I had somebody answer and win. They won a free one-on-one tutorial session with me, guys, for a topic of their interest, whatever topic they wanted. So I had a meet with a student last week. So I'm gonna put questions on my Instagram. So make sure you're on the Instagram. I put a question for you. You have the day to work it out, and then in the morning I put the answer and I'll select randomly a winner, right? I did that last week. So what I'm saying is for this week, I can give you some questions for you to work on your own, and then you be communicating with me on that. And then maybe next week we'll do maybe 1 or 2 past paper questions on this, and then we move to the next topic. Let me know what you guys think on that. Because the thing is, I don't want to rush the material and have you not understand it. Like, I'd very much rather, I mean, I'm being honest, like I'd rather spend this entire month, this free month on mole concept, and know that at the end of the month, you know all things mole concept, rather than me rushing to the oxidation and reduction and electrochemistry, and you still don't understand moles. Like that, I gain nothing from that, and I don't think you would either. So like, I would very much rather spend the entire month on mole concept and know that you are solid on mole concept rather than doing 3 different topics. So let me know what you guys think about that. Let me know what you think. Let me know in the chat right now so I can plan my week accordingly. Just let me know. Have a conversation with me, guys. I don't want to be a dictator. I want you guys to tell me what you want, because I'm here for you, not for me, right? So let me know what you want. Let me clear that. I see people in the chat talking and saying a lot of things. Let me know. You can unmute yourself and talk to me, talk to me. I am speaking, so you can talk to me.
You want to give us a homework or something before you go off?
I could. I'm gonna, let me see. Maybe I could drop that link in the chat. How about that? Let's see. Let me see if I can do that. I'm gonna put a link in the chat for you to follow to do those questions. I think I can give you both. Actually, I have 2 more concept quiz. And I think I can give you both. So let me drop this link in the chat and let me know if you can access it, okay? Let's see, I'm gonna give you this one. I gave it to some people last week who had requested it, but here it goes for all of you who are here. So can somebody click that link for me real quick and let me know if you can access it? And then I'm gonna put another one. That's our second mole concept quiz. I want you guys to practice this stuff, like practice it and get comfortable with it. I just sent you guys 2 links. So that's a mole concept quiz 1 and a mole concept quiz 2. So click the link and let me know if it works for you.
Yes,
Yes,
working.
What was that day, Chanel?
It's working, miss.
Okay, so there you go. You have two more concepts with Beyonce it works. Beyonce says it works. Anik says it works. Yeah, so just do those, work through those for me. It's a wide range of questions, right? To test your ability to convert mass to moles, to calculate molar mass, to use Avogadro's law, to balance equation, to figure out ratios. So you should honestly, you should be able to do all of those questions. You should be able to answer all of those. So if you run into a problem, let me know. You can DM me on Instagram, you can send me an email, or however it is that you communicate with me, you can communicate with me and let me know if you have any problems with that. But you, based on what we covered today and last week, you should be able to do all of those questions. Okay, guys? So let's wrap up here for today. I'm excited. I'm happy to see that it was really good for you guys. Based on what I'm seeing in the chat, is that everybody thought it was very helpful for them, and that's my goal, right? So I'm happy to know that. So do that quiz for me and let me know where you guys are. And based on that, because I'll see how you do as well, and you also get feedback in real time. Well, at least for the first one, because the first one is only multiple choice. So I'll see how you're doing, and then I'll know if I should keep moving forward with different topics, or if you guys want me to spend more time on this. Let me know. Either way, I'm here for you. So I am at your whatever it is that you want, let me know. Okay. So I gave you 2 quizzes. Do that and be communicating with me. Look out on our Instagram for free giveaways. You might win a free one-on-one session with me, so you can talk to me one-on-one about what it is that you want to delve into deeper. And then also subscribe to the YouTube channel, watch this playback on YouTube so you can see how we worked out the things, right? So as you're going through your quiz, be sure to watch back this on YouTube. Okay, guys? So thank you so much for coming, for showing up for yourselves, really, and taking ownership of your learning. I want you guys to do well. I want you guys to say at the end of summer that you nailed it. Like chemistry is in the bag. You are ready to move on, whether it's that you want to do nursing, you want to do engineering, you want to go UE Med or Med anyway, Harvard Med, anywhere you want to go. Like I want to be sure that chemistry is not your hindrance. Chemistry is not your limiting factor, right? It's not the limiting reagent. Maybe it's in excess, right? It's excess. You have more, all the good grades in chemistry. So chemistry is not going to hold you back. That is my hope for you. And I know that's your hope for yourself too. All right. So have a great rest of your Sunday. Do that quiz and I will see you again next week. Same time, same place. So have a great week. Okay, guys? Bye.
Bye, miss.
Bye.